This section examines combustion control. Approximately 60% of emissions from an uncontrolled vehicle engine come from the exhaust, a result of combustion of the fuel and the air. To reduce these emissions, some devices or systems control the combustion process itself, while others treat the resulting exhaust gases. Most modern vehicles use a combination. Carburetors meet emission standards by maintaining accurate mixture control over a full range of engine conditions. To achieve this, most carburetors require an air supply at constant temperature. A heated air inlet system uses hot air collected from near the exhaust manifold and mixes it with outside air. One control system uses a temperature-sensitive valve inside the air cleaner. It operates a flap that blends the hot air with cool air, so that the carburetor receives air at about 40 degrees Celsius, regardless of outside air temperature. Maintenance of this temperature assists vaporization of the fuel, particularly when the engine is cold. Vaporization is also assisted by heating the intake manifold, normally by circulating hot liquid coolant through passages in the manifold. If a manifold is too cold, fuel condenses on its inner surfaces, which will create a lean mixture and may cause incomplete combustion. Carbon monoxide and hydrocarbon emissions are highest from a cold engine. Changes in operating conditions can change mixture conditions within the manifold. If a carbureted engine is being driven at moderate speed and the throttle is suddenly closed, any fuel condensed on the manifold walls is drawn into the cylinders. The low pressure in the manifold also acts on the idle circuit in the carburetor to cause a larger amount of fuel to flow from the idle discharge port. All of these factors enrich the mixture entering the engine. There is only a relatively small quantity of mixture in the combustion chamber at this point, so turbulence tends to be poor. This can lead to incomplete combustion and the release of unburned gases into the exhaust. The throttle positioner and dashpot slow down the rate of closure of the throttle plate. This allows more time for air to enter the manifold and for the fuel to vaporize before the throttle is completely closed. A more combustible mixture is thus formed, which leads to complete combustion and a reduction in hydrocarbon and carbon monoxide emissions.